Hello everybody and welcome to your 55th C++ Made Easy HD tutorial. And this tutorial we're going to be learning about the erase function and the various find functions. So the erase function, first of all, is just like the substring function, but the difference is that it doesn't actually take a substring, it erases the substring. So I'm making this right now, and I'm going to say this is Peter, aka Peter, and I'm doing this for a specific reason. You will see later on in the tutorial. But if I say line.erase and I say erase from index 8, which would be where Peter is, then if I put this, it assumes that we mean from index 8 all the way to the end. So if I put cout line and I run this, just give it a second to build, then it says this is, and it erases everything else. But if I say from index 8 and I'm taking in 5 letters or something like that, then what will happen is that it will erase the word Peter and it will say this is aka Peter, like it says here. Okay, so the thing of the erase function is just like the substring function, but it erases it rather than taking a substring from the string. Okay, so now on to the find function. So what if we wanted to replace the word Peter right here? Okay, uh, now if we want to replace this word, Peter, we can easily call the line dot replace and count whatever and say this is from element 8 and it's 5 spaces, right? And that's fine, right? But say we had a super long string or whatever, right? And we didn't really want to count the spaces from then on, right? We could easily say that we use a for loop and do all that, but it's best if we use a find function which will handle that for us. So I'm going to create an index, and I'm going to say line dot find, and I'm going to say Peter. And what I'm going to do is put cout to that index, and then from what we're going to do is call line dot replace, and we're going to replace from the index, and we know Peter's 5 letters long, and then we're going to replace that with coding made easy. Okay, so this index, what it's gonna do is we're gonna call line dot find. It's gonna say Peter. The word Peter starts at index 8, so index should return the value 8. So we should see the value 8 in here. And when we call line dot replace, right, then we're gonna replace from index 8. We're replacing 5 letters, and we're replacing that word with coding made easy, and we will display that to the console window. So let's see what we get. It says 8. This is coding made easy, aka Peter. So we're saying, okay, it replaced the first Peter, but what about the second Peter? What if we want to replace the second Peter? Well, if we change line.find to line.rfind, what it does is that it searches in reverse order. So what this is doing is that it's searching until it finds the first Peter, right? Because we don't have it in a loop, right? We're not continuously finding. So it finds the first Peter, and then it stores that index into this index variable, which is index 8. But if we do rfind, it doesn't start from here, it starts looking from the end of the string. So then it will find this at first, store that index in our index variable, and then replace this Peter with coding made easy. So to show you what happens, so it says index 18, it says this is Peter, aka coding made easy. Okay, so that should be it, but it really isn't it, or it could be it, but there's a lot more things that we can look about finding. So what I'm going to do is we're going to say find first of Peter, right? And self-explanatory says find the first instance of Peter, or so you think, right? And I'm going to get rid of this this right here. And if we run this, we get the value 8. So you might be saying, okay, what's the difference between find first of and what's the difference between just regular find, right? Because they both start from the beginning and they just found the word Peter. Well, what I want you to do is change this capital T to a lowercase t, and let's run this. Now look, what just happened? It changed from an 8 to a 0. So why is that happening? Well, when we call find first of, it doesn't see this as a whole string. It sees all of these as individual characters, right? So if whichever one it finds first, so if it finds a capital P first, or a lowercase e first, or a lowercase t first, and we repeated another lowercase e, but we didn't really need that, or if it found a lowercase r first, then whichever one it finds first, then that will be the value of index. So in this case, it found a lowercase t first, and which is at index 0, and that's the value that we found. So if you want to locate a bunch of which characters first out of a bunch of different characters, then you can call find first of. Now all the other functions like this work the same. So if we put find and we say find last of, what it does is it starts from the end index, so it starts counting from here, and whichever one it finds first out of the letters or symbols that you put there, then it will return that index in here. And note that this can also take in special characters, so if it detects a new line or a tab or something first, the last or something, then it will return that index, okay? So let us look at find find first not of. So if we say find first not of, if it's not self-explanatory, it's like this. So if I put Peter and we run this, let's see what we get. We should get the answer 1. So we get 1. So why do we get 1? Well, it says find the first value that's not one of these values. So if first it gets the index t, t is one of these values, so we ignore that. It looks for h. H is not in any of these values, right? So therefore our new index is 1, since h is equal to 1. And the same thing with find last not of. If we run this program, we get the value 17. So if we look over here, all these letters are contained in here, so it ignores all of these, right? But I'm guessing the space is number 17. If we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the space is not this the space is the only one that's not of these letters, so we return that value. If we want to incorporate spaces, then we can put a space in there, and then if we run this, then the value we should get is 16 this time. So the value we get is 16. So since a is not a part of any of these values that we put in here, then that is the index that spits it out for us. So you might not see much uses for this now, but it has proven to be very useful. If you watch my Allegro or SFML tutorials, you'll see where I incorporate that when we get into tile mapping and such like that. So it can be very useful to use these functions. So that is it for this tutorial. I hope you enjoyed it. Thanks for watching, and don't forget to comment, rate, and subscribe, and bye.